Okay, so next up we have invited talk by Dr. Mak Roberts. Uh, he's a research scientist at the Naval Research Laboratory who works in automated planning, machine learning, and integrated planning and learning into interactive and applied AI systems. Sorry, I moved your slide a little bit.
Just the size of this text so I can actually read it. That's good. Thanks again to Sharon and to Harsha for the invitation, and thanks for the introduction. And I also want to thank some of the speakers that have come before me because I actually updated my slides earlier. That's part of the technical difficulties. I was excited to, it prompted a few other thoughts. So today I thought I would talk about a challenge problem that I'm using to frame my own personal research. I never thought I would be talking about this to an audience, but it's what I call my 25-year research challenge. So it seemed really appropriate for this audience. And when I was asked to talk about applications and challenges, it seemed like it was a nice way to frame it. Before I get there, I'll say the obligatory, I work for the Navy, but what I say is my own opinion, and I'm not the opinion of the Navy or the US government. So the easiest way to talk about this idea is to give an example, I think. So I'll give you my escalator pitch instead of an elevator pitch. Imagine two colleagues are meeting at the top of an escalator and they have less than a minute to catch up and coordinate whatever they're going to do. So here's an example conversation. Hi there, so-and-so. It's been too long. How are you and your partner? So-and-so. I believe the blanks because the names aren't critical here. But the point is that they're remembering these. Great, we moved to Vancouver last fall. Not a political comment. I just was trying to say to pick a nice city that I like. Congratulations. Is it a new job or are you still at company Y? Still at Y. More leadership these days. Hey, I saw you work at company Z now. Yes, though I still travel to Boston frequently. Speaking of Boston, how's your mother? She's doing great. Thanks for asking. I'm eating with so-and-so for lunch. Are you interested in joining? Sure. Great. Let's meet here at noon. So at the bottom, I've listed out some of the attributes of an agent that I think will be necessary to contribute to such a conversation. So I imagine a future where you have either embodied or software agents that are capable of this kind of long-term and short-term planning. I won't read through the whole list because part of the rest of the talk is to walk through each of the components. There are basically, let me just make sure I'm saying everything I wanted to say. So obviously natural language, I put uses language in the middle because I think that's a core piece of what's going on here. But the companion part is more just the platonic collegial sense, a buddy, a pal, a longtime friend with whom you share a long history of interaction. And so you see that here. So I still go to Boston frequently, which prompts the other person to say, oh, how's your mom? Outside of the context of this situation, if somebody else were to hear this, clearly they've got a long history that involves that person perhaps meeting their mother or in other conversations that we aren't seeing when we see just this short snippet. So those are the kinds of things that I think I'd like agents to do in the long run. I often think about these from different frames of reference. So, thinking about how to make a tractable, take that vision and make a tractable research question. So I think these are three reasonably good frames to come from when thinking about this conversational companion. So I'll have a slide about each one of these and then a couple of slides about gotchas. And that's more or less the content of what I wanted to say today. I'm really hoping to start more of a dialogue and conversation about this. Even though I'm using this conversational companions as a starting point, all of these attributes that we're talking about, I think, are true of many applications, not just this limited one I'm showing you. So the first frame is logic. Of course, this shouldn't be any surprise for folks here. What might be a surprise is the book I'm recommending. So rather than telling you to read a planning or book about planning or reasoning or logic, There's actually a great layperson's book called The Myth of Artificial Intelligence. I don't agree with everything that Eric Larson talks about, but this is a person who was on one of the original IBM Watson Jeopardy team. I think he was a linguist. And the hypothesis that he puts forward in the book is that the myth is the inevitability of superhuman intelligence. That's a philosophical question we can set aside. I think the main piece that I like about this book is that there are three branches of intelligence to consider from a computational perspective. Inductive, which is most of statistical machine learning, LLMs certainly fit in here. Basically, anytime you're taking data and compressing it into some model. Deductive, which I think also fits here for most of the logical planning perspectives that we've got, and mathematical logic. The one that he says is actually missing a lot from research is abductive reasoning. And if you don't know much about this, is basically those leaps of insight that happen when a human has collected all the data and then suddenly makes an insight, maybe from a fresh perspective or makes a jump. So the key things that I think that are related to this for conversational companions are that, and actually I somehow I didn't get this updated, but it's fine. I remember what I was wanting to say. So I do agree with Larson here, and I think that solutions to problems like this conversational companions will require all three of these approaches. The thing that is really important here is that representation is different for each of these kinds of problems. And we have to think about how to get those representations to work across these different barriers. So the frame here that I think of when I consider this problem is how do we get computational artifacts that are easy to use in these different kinds of pieces. The second frame is cognitive architectures. So there's if you're not familiar with what this is, basically it's a computational artifact that divides the work into forms of different kinds of memory. So the data lives in different they call them memories, and you have processes that work over those. There's a nice paper that characterizes a bunch of these different architectures. So it's called the Standard Model of Mind. I've got it cited on the bottom there. And the key thing that I take away from these is that you have long-term memories that tell you how to do things, what they mean, maybe ontologies, things that are more static or longer-term persistence. And then maybe even consolidated experience. So, this in that literature, they call it episodic memory. And then you have a working memory, more like a short-term memory that is the working space of what you're actually working on at the moment. And that's usually going to be smaller and faster, of course. And then you have processes like priming that take an external context, map it to a query in your long-term memory, and put that information in your short-term memory or your working memory. The key thing to remember here is that context is critical for almost all of the kinds of reasoning that we want an agent to do. So when I'm walking down an escalator or on an escalator, one of the contexts that I pay attention to is when it's going to end, right? So if I'm talking with somebody, I either have to navigate the conversation such that I gracefully end it at that point, or I have to get out of the way because there's going to be people coming from behind me, right? There's a physical aspect of this. Even if the agent is not physically being moved down the escalator with the human, they certainly need to understand that escalators have a certain kind of set of constraints that we behave around them. And that's the kind of thing I mean by context here. The third frame is, I wrote on the previous slide that it's model manipulation, but it's really symbol. But I wanted to clarify what I mean by symbol here. It's different from the usual symbolic or sub-symbolic sense. The definition I like to use comes from this book called Philosophy in a New Key. I'm not sure anybody in the room would even know what this is. It's something from my humanities degree. And this author, Susan Langer, posits that the mind is a symbol-making machine. She came out of the French semiotics, the 1950s literature. So As a simple making machine, the evidence for this hypothesis is language. It's rite or ritual. So if you participate in any sort of ritualistic behaviors, like when we graduate people from one cohort to the next, that's a rite. And then art, and she says art is the highest form of symbol making. The key idea here is that most thought is really a form of symbol manipulation. Language is, of course, central, but if you've ever played a piece of music or heard a piece of music, which doesn't have words in it, or seen an abstract piece of art that doesn't relate to reality in a concrete way, in a literal way, you can probably agree with the hypothesis that this kind of symbol manipulation and the meaning we attach to art can be something that goes beyond just language. From a computational perspective, the way I tend to think about this is framed well by the term deliberation function, which I'm borrowing from the automated planning and acting book. Essentially, I've listed a few of these. Generative AI can be thought of as another form of a deliberation function. It takes an input, manipulates it in some way, and puts it out. So that's an inductive form. But there are other ones like deductive and maybe abductive approaches that could work here for deliberation functions. So the key thing that I wanted to highlight here for its relationship to the application is that hybrid approaches are more likely to be beneficial here. Intelligence and multifaceted, dare I even use the word diverse these days, but it's actually really important to have a lot of different pieces that fit together. And actually, I had changed this because I didn't want to get sidetracked by this whole needs versus discrephies. I'd softened that bullet point a little bit, but I still think it's true that we want to move past one-dimensional ways of evaluating systems and think about things that are more complementary and how they benefit and how they don't benefit things. So those are the three frames that I think could be helpful directions to consider what to do next for conversational companions or applications like them. There are a few gotchas. So I'm okay with hallucination. Not me personally, but everybody, almost every time I hear these days when we start talking about it, people are really down on the fact that these models hallucinate. If I'm brainstorming, I don't want the box. I want to be outside of the box. That is the very definition of it. So why not just embrace it and accept that it is a part of the way LLMs work? It's actually a part of the way inductive processes work. We're never going to get rid of that. So all models hallucinate. Some do it better than others. And I think our job here is to characterize when and why we want it for a particular application, rather than to try to pull it down. Bias, I had a customer recently say, I just want to eliminate the human bias in decision-making. And on the face of it, it might seem like a really negative comment. This person meant it in a positive way. They meant that we were going in as an evaluation team to solve the siloed and self-interested perspective that a single individual was applying to this particular domain, right? She wanted to try to eliminate some of that very strong bias. But the other side of it is bias is everywhere. I mean, we don't think we're going to get rid of it. It's in the data we use, but it's also in the algorithms we use. We know representation from no free lunch proofs, representation, algorithm, problem, all of those things work together for either the algorithm working well or not. So our job here is to figure out why. I'm wondering lately if it's time for us to certify some forms of AI systems in the way that other engineering disciplines do. We're in a building. We haven't even given a thought to the walls falling down. If you haven't given a hug to an engineer lately, maybe you should, because that's why we can enjoy big buildings and have lights that work for us. Okay. This was originally, so the AI mistakes part is really part of the bias conversation. The kinds of mistakes that humans make are kind of different than what you see LLMs or other inductive approaches. There's a slight difference, and lately when I'm reading websites and other things, I start reading and suddenly I go, this is an LLM. I can tell I don't know how I can tell, but I can just immediately tell I'm information gathering and I go, oh, this is an LLM page. I'm not interested. And I go search somewhere else. And I think that's different than the typos or grammatical kinds of problems I expect to see from a human writer, or jumps in logical missteps that human writers make. I've listed a few others. I think Michael earlier mentioned this computational cost. But there's from an environmental perspective, but also I wonder, are we creating another haves and have-nots? I mean, these models are gargantuanly expensive and not everybody has access to them. Just a little side breather before I finish here. So in some ways, AI, I think right now is a little bit like early batteries. I don't know if you've ever given any thought to the batteries that you carry around, but they're kind of dangerous things. If you want to look at a really scary thing, look up lithium ion shorted. They explode. They catch fire very quickly. I mean, little tiny shorts that aren't very impactful. So in some ways, AI is like that right now. But early batteries were actually these glass jars filled with liquids and heavy metals that were kind of dangerous for people to be around. And maybe AI is a little bit like that in some of the lessons that they cared about for making batteries bigger or safer or more reliable, more powerful, et cetera. Some of those questions could be useful for us to consider. There are other technologies too that are like that. So I've given you an overview of this sort of general area of the conversational companions, a snapshot of what I think are some interesting things to think about from that perspective. Hopefully I've given some prompt and we can have a good argument later. I have a shameless plug. 3 of the people that are working in our current group are on this job market or might be soon. I work for the federal government, so I'll leave it at that. But 2 of our postdocs, actually Morgan is here, raise your hand. So Morgan's over there. And she's actually going to be graduating from her postdoc in July. And I wish I could keep her longer, but funding being what it is. She got her PhD from Hector, who's also here. So I didn't plan this. And the topics that she works on are learning hierarchical planning models. She did some work on learning numeric planning models, but she's also been looking at learning PDDL and as well as HDN models. She's used CNN approaches and LLM approaches, and she's got a nice paper which is like a prospectus for where she thinks this could go in the plan for LLM workshop. So reach out to her if you're interested. Vincent's not here today, but he will be at AAAI this week. He's also a postdoc, but don't take him just yet because his goes all the way through December. But he did his PhD on game theory with Dana Now and Rena Decter at UMD. He did some work with me early in his postdoc on curriculum learning and has a nice for reinforcement learning, a nice AMS paper there. But he's actually really interested in LLMs, and I'm hopeful that he can connect with some of the people in the community here. And he also has a paper at the LLM workshop that's coming up next week. And then the last is David Porfirio. He's a postdoc that just recently was transitioned to a full-time employee, meaning he's in the fabled probationary employee status. So he's, I would say he's not on the job market, but I'm encouraging him to be open to this. And his topics might seem a little bit off from this community because he's mostly in the HRI space, but he created a tool that I sat down and I drew a goal network onto a tablet and pushed play and the robot did something. And I did that in about 10 minutes of interacting with the system. It's really cool. So he's interested in goal networks. He's interested in formal methods. He really loves planning. He actually downloaded Unified Planning and used it for his toolkit. He's got some nice AMOS and HRI papers. So he's not actually here. He's going to be at HRI. I'm leaving for HRI on Friday. But if you're interested in that topic, let me know and I can connect you with David. So thanks for letting me do the shameless plug. I'm concerned about these 3 folks. So getting back to the topic at hand. So my working hypothesis, which means I'm willing to, strong opinions weakly held, right? So I'd love to argue about this with anybody and think through some of this. I highlighted the key things that I talked about in here. I didn't include abduction for this step of it because I don't know I'm not even sure how we do computational abduction just yet. I'm not sure as a field we know. So I didn't include it in the short list of where we're headed maybe in the next 5 years, but I'd love to see it on there. There's probably some things that you think should be on there. So I've got a list of possible requirements, and I'm going to actually skip to the end and come back to this one. So I know people don't like it when I do that, but I'll come back to this one. So basically, the two questions I like to think about with respect to this theme is, how do we support long-running agents that converse with their human collaborators over long periods of time, right? And the other is what is the role of memory? And I mean memory from like a cognitive architecture perspective in explainable intelligence, or intelligence that can explain itself to us. So those are sort of the things that I think about when it comes to conversational companions. And as I promised, I'll back up to this slide because I think this is probably a good primer for questions. I should have started off by saying, and now for something completely different, right? Like so many technical talks, but yes, please.
It's not directly related to planning, but I'm just wondering, when you showed those three kind of three different architectures for compensation agent, is one preferred over the other in particular scenario? For example, if I'm conversing with Hayden, who is doing some form of research for me, versus I'm conversing with a friend of that agent. There's one preferred over the other, and what is your opinion?
Yeah, so the question is, do any of the frames that I presented here, the three frames, the logic, I've already forgotten them. Yeah, symbolic, and the other one. Are they going to change depending on what kind of agent we're constructing? That I think the answer is yes. Almost always you're going to have some I suppose in the escalator pitch, if the person started talking in a logical way, like of course they're being rational, saying, yeah, I would like to see you, or how's it going, or whatever. But, logic, some of forms of the logic may not be appropriate there. But we're certainly using some of the cognitive architecture, like the episodic history. Like I'm remembering things that I've talked with you about before. And I'm using that to cue questions that I have for you conversationally. How we do that is amazing to me, how we even accomplish that. But so I guess the answer is yes. I think some will be more emphasized than others. Right? If I came up to you with a word puzzle, my partner loves puzzles, right? These my little logical puzzles. And when we talk about those, of course, it's a constraint problem that we're playing with, trying, well, what if we're talking about just the solution as a sort of a cognitive object that we're arguing about? That feels very different than a sort of a conversation that I'm having with a friend, right? Yeah, that's a good question. Others? Yeah. Hector.
Thank you for the presentation. I wonder if something like ChatGPT doesn't already exhibit this kind of long-term and short-term memories, or there is something specific that they are related to these concepts?
No, I think that's a great question. So they do have a kind of working memory in that they've got this prompt, and the prompts have certainly gotten large enough that they're substantial, right? We can carry information forward between individual queries in a sort of like a working memory. But when, I still remember the first time I met you, and I remember the last time we talked, and I remember that one time, you came to NRL, and like there's all of these additional history that is part of our shared experience. And then I also know what papers you've written, and I know what a scientific paper is, and I know that you were professor, so I know what, so I know what those mean in terms of a social situation that we might have, right? So where does that knowledge fit for the LLM? I suppose you could argue it's baked in, but I might like to see something that's a little more queryable, right? like as in a knowledge graph. Like I can inspect a knowledge graph and I can actually fix a knowledge graph. There are other techniques too. I'm just giving an example. Yeah. I guess I'm dissatisfied with this idea that everything has to be an inductive process, that everything's just baked into one model that's this black box I can't inspect very well. Yeah. I don't know if that answers your question, but yeah. Yeah, so that's why I come from this cognitive architecture perspective, thinking that we probably need interfaces to forms of memory that are persistent and adaptable over time. And then you pull that context into the prompts. If you're using an LLM, then you would pull it in there. Well, yeah, go ahead. I can hear you.
I was curious if the comment you were making about objective risk, right? And you were saying something about how if I understood it right, about the computational model to be used for it. But that has been studied, right? Is there something in this context that you're talking about? Because objective reasoning in general, I mean, you're in the cognitive system community, you understand there are methods.
Of course, of course.
That's very closely related to drawing explanations and stuff as well.
I completely agree. But the amount of work that I'm aware of, maybe you're aware of more work than me, the amount of work I'm aware of is much less than the inductive machine learning or even the deductive forms of work that we've done. Yeah, so that's my only point, that I think we might need more of it. Again, I'm not sure we need that in the short term. We could probably get pretty far. Yeah. Yeah, and I'm thinking of Matt Molyneux's work as another example, who worked on some of this, and John Clear, and like there's a bunch of work that's from the history of that. So yeah. Michael? Or
we have that. So I'll start a little bit further away. So you were talking about hallucination, for the lack of better word, you don't mind, and you said that it's like thinking outside of the box. But I think it's like how far outside of the box you are, right? I think what people mean by hallucinations is way far, right? Way outside. It's not related to the box at all. So that do we need like ways of validate all these? Because this seems like a bunch of tasks that we need to be able to perform separately and together, right? But do we need to have validators for these tasks and measures on how well?
yeah, so
yeah, some thoughts about
yes, absolutely. And by saying that I'm okay with hallucination, I didn't mean to imply that it's always good to have it. I just like I think it's going to be very hard to completely eliminate it, which seems to be the emphasis right now.
Oh, no.
Reduce.
Yeah,
Yeah.
I was with you on that. Right?
Yeah. So I guess my thinking is just that we, if you really want a deductive process, why are you using an inductive one? That's really the question I would ask. Like if you really want a plan, why not just use a planner? We're on the same side of the argument now,
Yeah.
which is not as exciting, but yeah. So, yeah.
Yeah.
Thank you, Mac.
Thanks.